An electroscope is a device that can be used to detect the presence of an electric charge. When a charged rod touches an electroscope, the whole electroscope takes on the charge of the rod. The leaves diverge because like charges repel. When the finger touches the top of the electroscope, it gains or loses electrons, and the balance between the electrons and protons is restored. In this presentation, I will explain how electric charge is transferred from a positive or negative body to one that's neutral. In order to understand what is happening when a charged object touches an electroscope, you need to know the three rules of static electricity. Opposite charges attract, like charges repel, and only electrons move when a body is exposed to an outside field. When a negatively charged body touches a neutral electroscope, a small portion of the excess electrons in the rod move into the electroscope, giving it a net negative charge. Since the leaves on the bottom of the electroscope are both negative, they repel, because likes repel. Let's take a second look at the process. The leaves at the bottom of the electroscope hang downward since no net charge is present. Each leaf is neutral, so they neither attract or repel. When some excess electrons move from the rod to the electroscope, there are now more electrons than protons. Both leaves are now negative, and this causes them to repel. When the rod is removed, the plastic collar at the top of the electroscope prevents the excess charges from leaving, so the electroscope maintains its negative charge. When a positive rod touches an electroscope, the leaves diverge or separate just like they did with the negative rod, but in this case the electrons move in the opposite direction. The positive rod attracts a small portion of the mobile electrons in the electroscope, and they move into the rod. This is because of the electrostatic principle that states that opposites attract. Let's look at what's happening at the atomic level. An uncharged electroscope has an equal number of protons and electrons, so the leaves hang straight down. When the positive rod touches the top of the electroscope, a small portion of the negative mobile electrons are attracted into the rod. When the electrons leave the electroscope, the net charge in the whole electroscope is now positive, and since likes repel, the leaves on the bottom of the electroscope diverge. The electroscope starts out at neutral, but when the electrons are attracted into the rod, the positively charged protons outnumber the electrons. When the rod is removed, the electroscope maintains its positive charge. When you bring a rod near an electroscope, the leaves diverge, but if you bring the rod back without touching the electroscope, the leaves return to the original position. Let's talk about what's going on here. When the positive rod comes near, the mobile electrons are drawn upward, and this causes the top of the electroscope to become negative, and the bottom of the electroscope to become positive. Since no charge has left the electroscope, the net charge is still neutral. If you brought a negative rod near an electroscope without touching, the leaves diverge just as they did with the positive rod. At the atomic level, electrons move in the opposite direction now. Before the rod comes near, the leaves at the bottom of the electroscope are neutral, so they point straight down. When the positive rod comes near, its electric field attracts a small portion of the electrons upward to the top. This gives the top of the electroscope a net negative charge and the bottom of the electroscope a net positive charge. Since no electrons are lost or gained, the net charge the entire time is zero. Can you select the graphic on the right that correctly shows the electron distribution of a neutral electroscope near a positive rod? Choices 1 and 3 do not show a neutral electroscope, so we can eliminate them. Choice 3 can be eliminated because electrons would be attracted towards the positive rod, not repelled. Choice 4 is correct because it shows that the mobile electrons would be attracted upward towards the positive rod because, of course, opposites attract. Let's look at this question. The motion of the leaves results from the electrons moving from when the rod is brought near the electroscope, the mobile electrons would be drawn toward the rod because opposites attract. When the rod is removed, the electrons spread out evenly and return to the leaves. Which diagram best represents the charge distribution on three neutral spheres when a positively charged rod is brought near sphere X but does not touch it? Choice 4 is correct because it shows a movement of electrons towards the positive rod. What you need to know is each one of these spheres is metal, and the electrons can move from metal to metal, so they move all the way to the left to be near the positive rod. Before I end this presentation, I want to remind you of the three big rules of static electricity. Opposite charges attract, like charges repel, and only electrons move. This is the end of my presentation on how an electroscope behaves in the presence of a charge.